In our last video, I walked you through how to set up a server that's capable of 40 plots per day. In the comments, there was a lot of interest in regards to setting up the plot manager that allows you to stagger your plots to get 40 plots per day out of this machine. I figured it'd be a good time to make a quick follow-up video walking you through how to set up Chia and also how to set up the plot manager to get the most out of your new system. So let's go over why you'd want to use a separate plot manager, especially one from a command line. Well, the Chia GUI plotting leaves a lot to be desired. I don't suggest you use it long term. I think it's great to initially get you started, and if you're just not comfortable using CLI, then it might be a good solution just in general for you. But if you're really serious and you want to plot the most plots you can out of your system, then I highly encourage you to check out something like Plotman or, as we'll be covering today, the Swar Plot Manager. The Swar Plot Manager is unique in that it's really cross-platform capable, so you can run it in Windows or you can run it in Linux, and it's pretty easy to set up. And so I'm going to cover that today with you, and just know that the main reason why you'd want to use something like this is some of the shortcomings of the Chia GUI plot management system and plotting in general. If you do run the GUI again and the application crashes, you will lose whatever plots are in progress. So you might not want to run the Chia GUI on multiple machines. If you haven't set up different harvesters, that could be another reason why you'd want to do this. But now I'll go into how to actually set all this up and get it running. The first thing you're going to want to do is go download Python. If you go to python.org/downloads, you can actually find the latest version. And upon downloading it and installing it, you'll want to make sure that you check a few extra options. Is to check the box that says add Python to environment variables. The reason this is important is when you're in the command line, if you don't check this box, you'll have to type in the full path to the Python directory to actually execute Python scripts. So after you check this box, you can go ahead and click install. It's going to ask you for an administrator, most likely if you didn't launch it as an administrator. Once you've installed Python, you'll want to go down to the video description of this video, as I've linked to the Swar Plot Manager GitHub repo. Once you click on the link to the Swar Plot Manager GitHub page, you'll notice at the top there's a green button that says code. If you click the code button, at the bottom it'll say download zip. You'll want to go ahead and download that file, put it in a directory that you'll be able to access here in a moment, because you're going to want to extract the zip file. So once you're finished downloading the file, you'll want to extract it. I suggest putting it in a directory that's easy to navigate to from a command line. After you're done extracting the zip file, you're going to want to open up a command prompt. You can do this by holding the window key down, hitting R, typing in cmd.exe, and hitting the return key. Once the command prompt is open, you're going to want to change directory, so cd space wherever the path is that you put the extracted folder for the Swar Chia Plot Manager. And once you're in the directory, you can do a dir and confirm that there's a requirements.txt file. And if you see the requirements.txt file, you're going to use the command pip space install space -r space requirements.txt. You'll hit the return key, and this will install the requirements. You'll wait for this to finish installing. And once it's finished installing, you can go ahead and follow the rest of the instructions here. You'll notice that there is a config.yaml file that you'll want to copy and paste into the directory that the Swar Plot Manager is in. Once you're done downloading the Plot Manager, you're going to want to install Chia. So to do that, you just go to chia.net, and at the very top in the right side, there's a big Install Chia Blockchain button. Depending on your operating system, after you click that button, you're going to want to select whatever's appropriate for you. I'm doing this in Windows, this tutorial. There's a lot of other tutorials out there, including one from Coin Breakthrough on a Mac, and I highly suggest you go check that out. Coin Breakthrough has a really great channel. Once you're done downloading the Chia blockchain installer, you're going to want to launch it, and it does all the work for you from there. After it's done installing, you're going to want to generate a key. I'm not going to go into too much detail here about what that means. There's a lot of great videos about this, and I'll include a couple videos that walk you through the installer and what the mnemonic key is. But for this video, this is more geared towards setting up and using the plot manager itself. So it's really important you install the Chia blockchain installer and generate your key before you try to run the Swar plot manager. It will fail if you try to do these steps in reverse. So I haven't really gone into too much detail about the destination directories when you're plotting. It's pretty self-explanatory. Basically, the temporary directory is the directory used to generate plots while you're plotting. Once you're actually done plotting, the final step, so there's 4 phases in total, and the final step is the copy step. And the copy step copies the file from your temporary directory once it's all completed, all 4 phases, and moves it to your destination directory. So now we can get into the main part of this video, which is configuring the plot manager itself. After you've extracted the Swar plot manager after downloading it from the GitHub repo, you're going to want to navigate into the Swar Chia plot manager main directory. Inside of that directory, there's a file called config.yaml.default. You're going to want to copy that file and paste it in the same directory and delete the .default at the end. That is your configuration for the Swar plot manager. Inside of that config file, the first thing you'll notice is there's a Chia location field at the very top after all the 5 commented lines. That Chia location field is actually the path to the Chia daemon. So there's a couple examples above it, one for Windows and one for Linux. In this example, I'm using Windows, and I'll try to make a Linux example later. But the path is pretty consistent. The only thing that potentially changes is the app-1.1.x, which is kind of in the middle of that configuration line. That is the Chia blockchain version that you're running. So if you're running 1.1.1 or 1.1.2 or 1.1.3, you're going to want to change this. But I'm running 1.1.4. So I'm going to set it to 1.1.4, and then I'm running this from my user Alex that you can see there. And so that's the path for the Chia daemon. After that, there's a folder path for the log itself, and this is where it's going to set your plot logs. These can be really useful later if you want to dig through and figure out how much time each plot took. I've actually set this all up in Elasticsearch, and I have a pretty good visualization dashboard that I'll show a little bit later. But set your folder path for the plotter log files in this field here. And then the next section is the settings that'll be used by the view. So the check interval is the amount of time that it takes to update the view screen, which I'll get into in a moment. But this is really just the status, I guess you could call it, of what's happening, how many plots there are, what percent they are. And so I typically just leave these settings as default. And then there's a notification section, and I'm not going to go over that. That could be an entire video. It's pretty cool, though. If you have a Discord, there's an API hook for that. You can have it play audio when the plot manager starts and when plots have completed. But we're going to skip past all of that and just leave it as disabled, the 4 different sections there. The next section is the phase progress settings themselves. So these are kind of used to dictate when a phase ends in the progress bar. So it's supposed to reflect where the different plots are and what phase they're in. I typically kind of leave these alone. If you really want to get advanced, you can play around with them. But the default settings are actually pretty good. And for tuning, which I think would be an entirely different video, we could go over some of this. But the default settings should work great for you, at least to start. The next setting that you're going to see is the global setting for max concurrent plots. So this setting is the maximum number of plots that your system can handle. So because we were setting this up on a T5810 with an E5 2699 V3 Xeon processor, I would set the max plots to something like 19 or 20 at first, because that is probably the maximum number of concurrent plots you want to run. So now we're going to get into the meat of the configuration of the Swar plot manager. This is the job section. So we're going to go through each line here, and it's important that you understand what each of these lines means in order to be able to tune the system. The very first line is the name of the job itself. So this is kind of an arbitrary line. It's important in that it references the job in general. So if you have multiple NVMe drives, you could break the NVMe drives apart into different jobs if you wanted to set different settings for each drive. If the drives are identical, you could just give the job one name, and that's another way to do that. You'll have to play around with this, but this is just the overall name of the job itself. There's a max plots field, which is really only specific to that current manager that's running. So if you restart the manager, this variable gets restarted as well. And it even says here it's really to help with short-term plotting, but I wouldn't probably change this setting at first. I would really just use this max concurrent setting for the overall total number of plots. This setting I think is set by default to 999. And so the next two settings are the keys settings. So by default, if you don't set these farmer public key and pool key fields, it's going to just use your default keys. So this is probably fine for most of you, unless you're getting into more advanced configurations of this and you have harvesters set up separately from your farmer, or you join a pool, which is supposed to be coming May 17th, thankfully. And shout out to the Chia team for making that happen. I think people are maybe treating them a little bit too poorly for releasing pools late, but I would say they're releasing them on time, considering releasing mainnet and releasing this to be tradable was probably a much bigger priority, and I appreciate that. So the next field is the temporary directory, and this is really important because this is the directory that you're going to be plotting to. So when you're building plots, this is where they get built. So this is typically your NVMe or SATA SSD drive. You're going to want to use fast storage for this, because if you don't, it can be incredibly slow. There's an optional temporary to directory, but this is a little bit more advanced. I would probably say in the second follow-up video that I make here with a more advanced walkthrough, I'll go over some of that. The destination directory is self-explanatory. The destination directory is where it puts the plot after it's done plotting. So plots typically land on a temporary directory, and once they're finished, then they get moved over or copied over to your destination directory. The file that gets copied is typically the .tmp temp file, and then it gets renamed to .plot.plot. So this is going to be your slow storage, your big 12 terabyte USB drive or SATA drive. And this is going to be your NVMe or SATA SSD temporary drives. I went over some of this in a previous video, and I highly encourage you to watch that to get an understanding of what a temporary directory is and how much space is needed per plot. But in this video, we're going to just move on. The size is the K value, and I don't see any reason why people would want to start with anything other than K32. So I would just leave the size field by default what it is. The bit field is also typically set to true, and I encourage you to use bit field. So I would probably leave that as default, especially at first. The threads is the number of threads that will be assigned to the plotter. So it calls out here that only phase 1, and as of the making of this video, only phase 1 can use more than one thread. So really this just speeds up phase 1. All the other phases are still single-threaded, which can actually help. And if you have enough cores to feed it, it might make sense to give it more than one core or one thread for this section. The number of buckets defaults to 128, and I would probably just leave that as 128. The memory buffer is the amount of memory assigned to this process. So Chia defaults to 3,390 megabytes of memory buffer. I suggest you do the same. I think that actually works really well, unless you have a lot of extra RAM. I don't know how much this really helps when plotting. I haven't really seen a whole lot of benefit to increasing this number, though it can help. I think it's very dependent upon your configuration specifically. So you can play around with this and see what kind of times you can get plotting wise by giving it more memory than the default 3,390 megabytes. The next setting is the max concurrent. And this setting is the maximum number of plots you can have for this job at any given time. So obviously it's easy to read that, but what that actually means is this is the maximum number of plots that will be going or running concurrently at any given time for this job that you're configuring. So we can use a 1 terabyte NVMe drive as an example here. I typically recommend to set this to something that's conservative at first, and then monitor the drive usage and see how much data is being taken up on the drive at peak while this job is running over the course of 12 or 24 hours. And then you can go up or down from there. But if you start at too aggressive of a setting, so as a 1 terabyte drive example, a plot can take at maximum 256 gigabytes of storage, then what I would do is typically set this to 3 or 4 for a 1 terabyte drive, which would fill the drive up theoretically. But I would give it a 60 or 45 minute stagger, which is configured here, and we'll get to that in a moment. And then I would increase this number over the course of 12 or 24 hours, depending on how much storage was used. I've typically seen that you can get away with 4 plots on a 1 terabyte drive and 8 plots on a 2 terabyte drive, as long as you have a stagger time of 60 minutes or 45 minutes in some cases. So again, I would probably set this to 3 or 4, set the stagger time to 45 minutes or 60 minutes, watch the drive, see how much it gets filled up. If the drive fills up too early, you're going to have to kill the plots and delete the temporary space and start over. So it's really crucial that you set this to a low enough number that won't fill the drive up at first, and then slowly increase it as you kind of monitor and make sure that the drive can handle more plots. There's also resource contingency issues. So your drive might have enough space, but if you put too many max concurrent plots on it at the same time, then you're going to slow it down tremendously. And so kind of keeping an eye on how long the plots take as you increase this number and how much space is used is really critical to try and drive the efficiency up of the plotting itself. And the next step is the max concurrent with start early. So this is the maximum number of plots for this job, including the phases that start early. It's kind of self-explanatory. And so the next step is the stagger minutes configuration line. So this is the total number of minutes to stagger the plots and wait before the next job is kicked off. So you can set this to 0 if you want, but then it's just going to kick all the jobs off at the same time, which isn't the best way to get efficiency out of this, which I kind of described in our last video. And I'll kind of briefly touch on that at the end of this video as well. I typically set this to 60 minutes. It's kind of a safe number, and you can go up or down from there. You'll see below in my configuration that I've actually decreased that quite a bit, but I typically do start with 60 minutes, and that's a pretty safe number to try and drive efficiency up from there. So this next line is the max for phase 1, and this is the maximum number of plots that can be in phase 1 at any given time for this job. So phase 1 is a really difficult phase in terms of storage I/O and CPU. And so what you want to do is keep this number somewhat low so you can have a high max concurrent number for the job, which is how many total plots will be run at any given time, and then a lower max for phase 1 number. So that'll keep a smaller number of plots in phase 1 without kicking off more jobs. And by doing this, what you also do is you distribute the plots more evenly across the different phases. And so when you stagger all the phases apart, what you end up doing is kind of balancing the total amount of CPU needed at any given moment, the total amount of storage needed at any given moment, and it really allows you to get the most out of your system. So it's hard to give you an example of what to set this to. I've typically set it pretty conservatively at first and then gone more aggressive and increase the number over time once I figure out what the NVMe drives that I have can handle. The next configuration line is the start early concurrency phase. So this is the phase in which you want the plot to start early. It's typically recommended to just use phase 4. So this will kick off a job early before the next one finishes. Typically when the job is in its final phase and it's copying the data to the destination directory, what that means is you're going to kick off a job while the file copy's happening, which is totally fine. And typically that doesn't really interfere with or slow down anything. It also can kick off jobs that are actually in phase 4 a little bit early. So you'll have like a couple jobs start in phase 1 while your jobs are in phase 4. I kind of suggest just to leave this at phase 4. I wouldn't increase it unless you really know what you're doing, because you can fill up your drives and all sorts of bad things can happen. The next configuration line is the total number of seconds to wait before a new plot gets kicked off when the start early phase has been detected. So it's pretty self-explanatory. This is how long it's going to wait before plots start when the start early phase is ready to go. So total number of seconds, if you have 2 jobs that get kicked into phase 4, this is set to 10 seconds, so it's not going to start another job until 10 seconds passes. And temporary to destination sync, I wouldn't really play around with that, and I can go into more detail in a future video. But we can go straight into the configuration now. These are all commented out, so the configuration examples that it gives you are really useful. You can see this is an example I'm going to give you based on a drive that some of you might have. These are 4 2 terabyte Evo Plus drives. And so I've got the max plots just set to default. This is on the farmer, so I don't have this set, so it's just using my default keys. The temporary directory is where it's going to put the plots, and then I don't have any temporary to directory. This is the destination of where it's going to put the plot once it's done. So I have the size set to 32, which is default, bit field set to true, which is default. I actually have threads set to 8. I don't necessarily recommend you do this, but I'm running this on a Threadripper system. So, there's a little more CPU available for this job, obviously. So eight threads for phase 1 is totally fine and obviously not causing me any resource issues. The total buckets is the default setting. I have memory set to 3390. I have a lot of RAM in this system, but I'm not really using all of it, and I'm trying to get the most plots that I can. So I don't really want to run out of memory. I have max concurrent set to 25. It never really hits 25 because I have a stagger time of 35 minutes set here. And then I've got a max concurrent with start early set to 25 as well. I've got max for phase 1 set to 5. I think I'm probably going to change that to 4 now. I've played around with these settings a little bit, and I haven't really gotten better performance out of setting this to 5. I think it slowed it down by 30 minutes or 45 minutes a plot. I have the concurrency start early phase to 4, and then I just have everything else as default for this. So these 4 Samsung Evo Plus drives are kind of chugging away, doing lots of plots. They could get to 25 plots, but that never really happens because of the start early and total number of phase 4 plots. But this is about what I've gotten for efficiency. I'm sure this can be optimized a hell of a lot more. I just haven't really taken the time to optimize this job yet. So that's kind of an overview. And if you want to have more than one job, it's as simple as copying and pasting the settings for another block of job, I guess. This is a better way of putting it. So this is an MP600 drive. You can kind of see it's 1 2 terabyte drive. I've got a max concurrent of 9 plots, which doesn't seem to be causing any problems, even though if you did the math, that actually would fill up the 2 terabyte drive. So this works really well for this drive, I've noticed, and 8 threads because I have a lot of extra cores and threads for use here. I've got a stagger time here of 45 minutes because it's only one drive. It has a little bit of a harder time handling the three phase one plots that I have going. These two drives are inherently different from each other in terms of performance. This Evo drive does use a little bit of caching, so I only have 4 for phase one, and you'll notice I have 3 for this MP600. The MP600 is quite a bit faster than these Evo Plus drives, just in terms of overall throughput. But my suggestion is to just play around, fine-tune these settings, and you'll find that certain changes can slow down or speed up the total amount of plots per day you can get. So now let's walk through actually kicking off some jobs and getting started. I highly encourage you not to be impatient during this process. You really do want to have a stagger time of 30 or 60 minutes. And if you increase this too, or decrease it too much, what you'll end up doing is slowing down your overall performance of your system, and you won't be able to get nearly as many concurrent plots at a time out of it. So with that disclaimer, I'm going to go ahead and jump into this. You'll see that this is mostly done in a command line in Windows for this example, but once you launch a command line, you're going to want to navigate into the directory that you've extracted the Swar plot manager to. So for me, I threw it on my desktop. So that's where it is. Just change directory, desktop, change directory to the Swar plot directory. And you look in there, you see all the files. To launch it, really, it's pretty straightforward and it's very simple. It's as long as you install the Python variable, environmental variable, when you install Python, it's just Python space manager.py space start. That's it. That's all you have to do. I already have mine started, so I'm going to view it. Really, those are two simple commands, start and view. It's going to take a minute here because I have quite a few plots already running. After you hit start, it's going to use your configuration lines to determine how many plots to kick off. You can see I have had this manager here running for about 3 hours. And so you'll see I have a chunk of plots in phase 2, a chunk of plots in phase 1, and all the plots in phase 1 are all the jobs that I have running here. So this lets you kind of monitor the progress of what's going on. You'll see this is 46% done. It's been going for 3 hours. And this is the job here that you see. So you'll notice that there are 1, 2, 3, 4 jobs with the 2 terabyte Evo Plus X4 name. And the reason for that is I have max for phase 1 set to 4. So it's not going to kick off any more phase 1 jobs until one of these jobs goes into phase 2. Once that happens, the next step that the plot manager takes is to evaluate the stagger minutes. So even if this job here jumps into phase 2 right now, it's not going to kick off another job. And the reason for that is because this job has only been going for 1 minute. So I have a 35-minute stagger time, and so it would require that this job gets to 35 minutes before it kicks off another 2 terabyte Evo Plus job. I know that probably sounds confusing, so I encourage you to pause and rewind to walk through that. But you can see I've got 4 jobs in phase 1. This job has been going for 1 minute. It will have to get to 35 minutes, and this job will have to get to phase 2 before the plot manager is going to start another job on this drive. So that's a best way I can describe it. And so to get out of this view, you hold Control and hit C. And so now you'll notice I'm back to a command line with the directory here. And so the next command that I want to teach you is Python space manager.py space restart. So when you type restart, what that does is reloads the config. So I'm going to show you a change that I'll make here. So I'm going to set this to 5, and I'm going to set the stagger minutes to 3. So I'm going to save this configuration line, and I'm going to restart the plot manager. It's going to take a second. Restarting the plot manager does not stop your plots. So the plots are still going. It's just going to reload the configuration. And I'm going to do Python space manager.py space view. You'll notice before we had 4 plots in phase 1. And if we look now, Give it a minute to load. We've got 5 plots in phase 1. 1, 2, 3, 4, 5. And the reason for that is I changed the max for phase 1 to 5, and I changed the stagger minutes to 3. So you'll see this hit 3 minutes and it kicked off another plot. I obviously don't want to keep it at 3, as that will surely lower my performance from testing that I've done. And so I'm going to go back into the plot manager, hold Control and hit C, and I'm going to restart the Python manager by typing python space manager.py space restart. And we're going to give that a minute. And now it's reloaded the config. Unfortunately, because I did change those 2 variables, the Python manager is not going to stop those plots. They're still going to be going. So if you make a mistake in your config and you restart it, and say you launch a bunch of different plots, you're going to have to manually go and clean that up. In this case, this drive's just going to be a little lower performance during this time, which I'm fine with. I might go and kill it and delete the files, but regardless, that's how that works. And so the next piece that I want to cover is something I actually didn't realize at first when I first started using this, which is if you change the destination directory or the temp directory, it will actually not recognize the previous jobs. And so my suggestion, if you need to make changes like that, is actually the same suggestion that the creator has, which is changing the max concurrent to 0 and the max start early to 0 and the max phase 1 to 0. It's probably unnecessary, and then just creating a new job. So if you need to change the destination of the job itself because maybe you filled up one of your hard drives, what you probably want to do is just set everything to 0 for the job you have so that it can keep track of the job, copy the whole section, paste it, and then change your destination to something like Y or whatever your new destination is. By doing it this way, it'll keep track of the old jobs. So I'm going to show you what happens if you don't do that. So I'm going to go ahead and just say, I want to put this job into the O drive, not to that directory that I'd specified a second ago. And I'm going to set all of this back to normal. I'm going to save the file, and then I'm going to restart the plot manager. So 2 things are going to happen here. 1, all of these previous jobs are going to be labeled ? And 2, it's going to start an entirely new set of jobs named 2TB Evo Plus -X4. The reason that's notable, again, is there's the new job. It's going to now create more jobs than I probably want on this drive because it doesn't know that these jobs are all part of this job because the destination changed. I know that might be a little bit confusing, but again, my suggestion to remedy this problem is to just simply create a new job, change the max concurrent for this job to 0. So that's it. That's how you set up the Swar plot manager. For the T5810 build in our previous video, what I would suggest is probably to have 2 2TB NVMe drives, and then you're going to want to have 2 jobs, 1 job for each drive. I would suggest 10 or fewer concurrent max plots with a stagger time of 60 minutes and a total of 3 jobs in phase 1 at a time. If you do that, you'll end up with roughly 20 plots at a 24-hour period. You'll do that twice. It'll take roughly between 8 to 12 hours to finish 20 plots, 10 per drive. And you'll accomplish that twice per day, which will get you somewhere around 40 plots per day. You can fine-tune this a little bit more and probably get even better numbers. And if you switch to Linux, which I'll cover in a future video, you'll get a 10-ish% performance improvement, which will get you even more plots per day out of the T5810 with an E5 2699 V3 Xeon processor. Thank you for watching the video. Please like and subscribe and comment below and let me know what I missed. I'm sure I didn't cover this completely, but I did the best I could. Tried to put this together somewhat quickly for you guys. so that you had a reference to go by and how to do this. Using the GUI plot manager is really terrible, as I said earlier. It's just slow, and if the application crashes, you'll actually lose all of your current plots, which is a pretty terrible feature. So my suggestion is to use something else like Plot Manager from Swar, or there's another one called Plotman that works really well, and we might cover that in a future video as well. But I appreciate your time, and I thank you for watching.